Twin paradox. Science fiction. Not quite. There's a paradox that brings it shockingly close to reality. The twin paradox. A thought experiment from Einstein's theory of relativity. It challenges our very understanding of time, space, and how they interact. It's not just a fascinating riddle. It's a glimpse into the mind-bending world of modern physics, where time can stretch, shrink, and behave in ways that defy intuition. The premise. The twin paradox begins with a simple premise. Two identical twins. One twin stays on Earth, living their everyday life, while the other boards a spacecraft that travels close to the speed of light. After completing their journey through space and returning to Earth, something extraordinary happens. The traveling twin is younger than the one who stayed behind. How is this possible? They're twins after all. They started at the same age. Shouldn't they have experienced time in the same way? The answer lies in Einstein's theory of special relativity, which describes how time and space are interconnected. One of the key principles of relativity is that time is not absolute. Instead, it's relative to the observer's motion. This means that the faster you move, especially at speeds approaching the speed of light, the slower time passes for you compared to someone who isn't moving as fast. This phenomenon is known as time dilation, and it's at the heart of the twin paradox. Time dilation in action. For the twin aboard the spacecraft, time moves more slowly because of their incredible speed. To them, the journey might feel like only a few years have passed. But for the twin on Earth, where time moves at its usual pace, decades could have gone by. When the traveling twin returns, they find their sibling significantly older, while they have barely aged. This isn't just a theoretical idea. It's a real effect that has been observed in experiments involving particles traveling at high speeds. The symmetry problem. At first glance, the paradox seems to raise a symmetry problem. If motion is relative, can't the traveling twin argue that it was their sibling who was moving, while they stayed still? Why should the traveling twin age more slowly? The resolution to this lies in the fact that the two twins experience different paths through spacetime. The traveling twin undergoes acceleration and deceleration as they leave Earth, turn around and return. This breaks the symmetry of the situation. In contrast, the twin on Earth remains in a single inertial frame of reference, experiencing no such changes in motion. Real-world applications. The twin paradox isn't just a thought experiment. It has practical implications. In fact, time dilation is a measurable effect. For example, GPS satellites orbiting Earth experience time dilation due to their high speeds and the weaker gravity at their altitude. To ensure that GPS systems work accurately, scientists have to account for this effect, adjusting the satellite clocks so they stay in sync with clocks on Earth. Without this adjustment, your GPS navigation would quickly become unreliable, challenging our assumptions about time. The paradox also challenges our everyday assumptions about time. We tend to think of time as a constant, ticking away at the same rate for everyone everywhere. But the twin paradox reveals that time is far more flexible than we imagine. It can stretch and compress, depending on your speed and location in the universe. This isn't just an abstract idea. It's a reality that has been confirmed by countless experiments and observations. Philosophical implications. The implications of the twin paradox extend beyond physics, touching on deep philosophical questions about time and existence. What does it mean for two people to experience time differently? How does relativity reshape our understanding of aging, identity, and memory? And if time itself can behave so strangely, what other surprises might the universe hold? Science fiction or science fact. One of the most fascinating aspects of the twin paradox is how it bridges the gap between science fiction and science fact. Concepts like time travel, interstellar exploration, and life at near-light speeds often seem fantastical. But the paradox shows us that these ideas are grounded in the fundamental laws of physics. It's not a question of whether time dilation is real. It's a question of how we might one day use it to explore the cosmos. A challenge to human intuition. Yet, the paradox also serves as a humbling reminder of the limits of human intuition. Our brains evolved to understand a world where speeds are slow, distances are short, and time feels constant. The twin paradox pushes us beyond these everyday experiences, forcing us to think in terms of a universe that operates on entirely different scales. It's a testament to the power of human curiosity and imagination, allowing us to glimpse a reality that lies far beyond our senses. Final thoughts. So what does the twin paradox teach us? It's more than just a quirk of physics, it's a profound insight into the nature of time and space. It challenges us to rethink what we know about reality, to question our assumptions, and to embrace the strange and wondrous truths of the universe. And perhaps most importantly, it reminds us that even the most familiar concepts, like time, can hold mysteries waiting to be discovered.